Alright, so here we are for a live stream. Just waiting on a few persons to get on board, and then we make progress. Alright. Alright, we're still waiting a bit, and then we'll actually begin. Okay. Alright, so welcome to the COMP1227 Marathon. Alright. In this live stream, I'll be covering what is required for the exam, as well as additional information in terms of practicing and what you're expected to know overall. Alright, so can everyone hear me clearly? Could someone just post in the live chat so that I can know if everything is quite fine and good? Alright, so let's begin. So I call this tutorial 1.5. Alright, So the very first thing that we'll be taking a look at is stacks, followed by queues. Then after we take a look at those, we'll be looking at higher order functions, and from that we'll take a look at maps, filter, fold R, or for some people you guys might know it as reduce, and we'll take a look at list comprehensions. Okay. All right, so before I work some examples, what I usually like to do is explain these topics so that you guys can understand it, because in section 2 of your exam, you're always guaranteed that you'll either get a queue question or a stack question. That is always a must. You will get a question surrounding one of these two data structures. All right. In the multiple choice section, you usually find these parts here: maps, filters, fold right, list comprehensions. But also in the second section, you'll usually have where you have some compound data structure. So compound data structure, where you have to extract some form of value. And usually you would do the extraction using map, filter, or some list comprehension to make some changes, or fold R. Alright? So, but the very first thing I'm going to go through is stacks and queues, followed by higher order functions, because map and filter is a higher order function. So I'll be explaining that first, then you guys will be able to learn the others. Alright? Cool. So let's get into the meat of the matter. So let's take a look at stacks. Now, what are stacks? Imagine you go into the store. So you're right here. You're going to the store, right? And you see them have a pile of red stripe cases going up, right? The employee who works there, the stocker, place this one first, followed by this one, then this one, then this one. So this one was the first one he placed down on the floor, followed by placing all the others on top. But when you actually go into that supermarket and you want a case, where do you pull it from? You're not gonna pull all the way from down there, because really and truly that is too much weight to actually be lifting off to actually get to that one. What you're naturally gonna do is walk up and pick the first one, the top one. Well, provided that your height is you're tall enough to actually reach it. So let's just assume that you're tall enough. You'd actually choose that one. And after you choose that one, so let me just X that off. That one is gone. The next customer that walks in, that customer is gonna choose the one that's below and move with that case. And then the next customer is gonna move with the other one. Then the next customer is move with the other one. That's what stack is. The employee, the first case of red stripe that he placed down is the last case that a customer will actually pick up. So the last one that was placed down is the first one that was taken up. So that's all stacks are. The last in is the first out. So we call that LIFO. Last in, first out. Cool? So that's all stacks are. Now let's take a look at another scenario. Alright. Another scenario now for queues. Now with queues, it's the other way around. You go to KFC and you have the worker that's right there. Say, may I get your order, please? If you take a look at KFC, I have this really and truly long line that no one really likes joining, personally. No one really likes joining that long line, but we all have to because of fairness. So persons all have to stand up and wait in this long line to get served. If you take a look at it, the first person in the line is the first person to get served. The last person that's actually in this line is the last person that's actually going to get served by that receptionist, right? That is what queues are. The first person in that line is the first person out to be served. So, first in, first out. That's all queues are. So we realize that there are two main data structures. Stacks, the last item that you put in is the first item you get out. Whereas with queues, the first item you put in, first item you take out. Alright? So these two data structures, what stacks and queues really and truly are, they are what we call an abstract data type. So abstract data type or data structure, whichever one you want to call it, it's the same thing. And the reason why it's abstract is because this is a simple concept that we're saying, okay, stacks, the last thing you put in is the first one you're going to get out. And for queues, the first thing you put in is the first thing you're going to get out. Abstraction simply means that we only care about the functionality. What really and truly are these data structures doing? We do not care about how it was done, we just know what should be done. So that's why it's called abstract. But for you now, you're a developer. You are the one who is going to build this data structure. So right now you actually care about how it is done as well as what is done. But the person who's going to use your code don't care about how it is done, just care about what is going to be done, which is for queues, first in, first out. And for stacks, last in, first out. Good? So let's actually see how we should actually go about doing this. Easiest way in which we can actually build our data structures is using list. Because a list data structure can grow in size. You might say, okay, well, there's another data structure that can grow in size, and there are dictionaries. But dictionaries is not really the best option, because with dictionaries, we do not keep a record of position. So if you have a dictionary where you have a key of 1 and a value of, let's say, letters, so we have a next key of 2, and we have this right here. We do not have a set position in memory where this key value pair is stored and this key value pair is stored. Each time, let's say you should assign this dictionary to the variable A. If you should restart a program and each time you assign that to the variable A and print A, you might find out that this order might not be the same. You might find out that the next time you print it, you might just get the 2 key first and the other key right behind it. So dictionaries don't keep a track of order. And for our data structures, order is very important. The last thing you put in is the first one we want out. So the order is important for stacks. For queues, the first thing that you put in is the first thing you want out. So order is important for queues. So therefore, dictionaries could never be the wise choice. So that's the reason why we use lists. Because with a list, we can grow in size, just like a dictionary can grow in size. And really and truly, there's no other data structure in Python that allows for this. dictionaries, and lists. Cool. So now when we take a look at this, let's try to work out how a stack data structure really and truly should look. So let me come here, get my pen. All right, so let's take a look at the stack. Remember we said for stacks, the last in is the first out, right? So if I have my list right here, cool. Let me change this color. Something brighter. So if I have my list right here, right? I'm saying the last thing in is the first out. If I add value to my list by adding it to the end, so that's the first value, and then I add another value, 6, 7, 12, 21. That is me adding to the end of the list, and we call this appending. So if you guys have never seen this word before, it's a unique method associated with lists. So you have the dot append method. So like if you have a list and we call it A, we can append a value to it by saying dot append, and I pass a new value to that list. What this will do, it will update A to now say 1, 2. For some of you guys, you might have learned another way. So if A is equal to that, you guys can do this, basically joining two lists together. That's another way of doing it, but stick to using the append method. Cool. All right, so now with that said and done, for stacks, because you're adding to the end of the list, so we're inserting always at the end of the list. So if we're saying the last inserted should be the first out, that means we should be doing something that's removing from that end. So therefore, lists also have a method called pop. And with pop, it takes a parameter, which is the index of where you should be removing information from that list. So now, as you guys have learned from 1126, is that you can access the information at the end of a list or a string by using negative indices. So negative index allow you to start from the reverse. So you start from the end, go all the way up. So if I have a -1, that's the end of the list. -2, that's the second to last in the end of the list. -3, you're going up. You get the gist. So if I want to remove the last thing in the list, I just simply say pop -1. Cool. So we add to the list using append, and we remove from the list using pop -1. All right. So that's how we do it for stacks. So now there are certain terminologies that are associated with stack, all right, which you must know and you must use in the examination, because this is what allows the abstraction. A person who understands stacks, and they should be able to call your code using these terminologies. So when we want to insert, we use the word push. When we want to remove, we use pop. When we want to retrieve the last value in that list, like get the last value out of that list without actually troubling our data structure, we use the terminology top. All right. And also for stacks, we usually want to check if it is empty, to ensure that we're working good, because we cannot get the top of a stack if it's empty. Neither can we remove from a stack if it is empty. So we need this is empty statement to check if our stack is empty. So these are the 4 terminologies we need to know. Cool. So now let's get digging to some actual coding. All right. So right here, let's start defining our stack data structures. All right. Now the first thing we need to do, we need to be able to make a stack, right? So we can have a function called stack, which actually returns a stack that we're making. Usually when you're making data structures, you tend to want to use a tuple, where the first index is the name of whatever data structure you're making. So we can just call this stack. And the second index is the actual information for a data structure. Now, based on what we said right here, we said that our data structure is actually a list. Our data structure is actually a list. So that means right here should be a list, right? So it should be a list. Cool? So this is how we make a stack. Now, based on the last thing that I mentioned, is that we need to have these stuff. We need to have a push function, a pop, a top, and a isEmpty. Let's start with the isEmpty function first. So we say isEmpty, and then isEmpty needs to take a stack, right? So I'm gonna say stk to represent a stack data structure. How do I check if it's empty? Where really and truly in this data structure is my stack? My stack is this list. So all I simply need to do is check if that list is empty. So all I can do is return stk. I retrieve that index, which is at index 1, because it's index 0 followed by index 1, and I check if it's equal to an empty list, and that's all. And the reason why I don't need to do this statement of saying, okay, if 1 equal that, then I return true, else I return false. The reason why I don't need to write my code like this, really and truly, it's a waste of time. Why? Because equivalent operator, less than or equal to operator, greater than operator, greater than or equal to, all of those stuff that are checking relationships between two stuff, they always return true or false. So I don't need to waste my time writing so much code. I just can just write this. I can just return this and it will automatically give me true or false. So try to learn to write a little bit of these shortcut ways in the exams, because time will be against you and you might have some harder questions that you need more time. So try to write as concise as possible. Alright? Now, after we've done the isEmpty, we can try this function. Let's try the push function. Alright? We're going to insert into that stack. So push, once again, we need to take a stack. I'm going to call mine stk. Now, how did we say we should push inside of a stack? Alright? How did we say it? We say we add one at a time. And how did we do that? We append by adding it to the end of that stack. So all I simply do is stk 1 dot append, and also I need a value to append to it. So this is gonna take a second parameter, and I just append it right here. Cool. So what basically is happening here is this: the push function takes two parameters, the actual stack, and the second parameter is the value that you want to insert into this stack. What we did right here was get that list, retrieve that list right there, and because we set the list as an append method, we call that append method and pass the value that we want to put in it. Cool. Now the next thing we're gonna do is the other function, the pop function. So we say def pop. Now pop really and truly is gonna remove from that list. We're not getting any value, we're just removing it out of the list. And I said earlier that to remove, we use the pop method once again for that list operation. I will pass -1 to remove the last value. So I just simply say stk index 1 to get that list dot pop, and I pass -1 to it. Cool. and that removes the value from my stack. Now the last function I have is top, right? And for top, I have stk, and remember I want to retrieve that value that's at the top. So I'm going to return the last value in that list. Remember, 1 gives you the last value in a list. That is our top. Cool. But let's take a look at this. Remember I said we cannot get the top of a stack, neither can we pop from a stack if it is empty, because if it is empty we're gonna get an error. That's the reason why I said the isEmpty function is necessary. So we can modify our pop and top function by checking if the list is not empty. So I'm saying if not is empty, then I do that. Cool. So all this is saying is empty takes a stack and tells you whether it's empty or not. So is empty is going to return true if it's empty, false if it's not. So we're saying if it's not empty, then we're going to pop from that stack, right? If it is empty, we're just not going to do anything. We're just going to let it be. Cool. Now for the top, now we can only return the top once it's not empty. So we do that same thing again. If not is empty and we pass our stack to it, then we're going to return that. Else, what we can simply do is print to that user that the stack is empty. Stack is empty, so we can't retrieve the top of that stack because it's really and truly empty, right? Now, for those of you who probably don't like that printing, you could also do something like this: return none. So it could be that for your program, you're saying none indicates that there's no value in that stack, right? So once it's empty, then we return none. For those of you who do not like that, you can simply print some message to the screen. So in the examination, if they didn't state you should print, you can either do the print or the return none. Okay, whichever one suits you best. Both of them works the same. Cool. Now the reason why I didn't say okay, you can return like -1 or something like that, that wouldn't be safe, because it could be that your stack is storing positive and negative values. Cool. And also returning a string wouldn't be good as well, because it could be that your stack is storing strings. So that none statement is best. Cool. So any questions? Everyone is good so far? I'm just here waiting on somebody in the live chat to just let me know if they're good so far. Based on what I'm seeing so far, no response. I'm guessing that's a consent, that everything is fine and dandy. Alright, so moving on, since I'm getting no response thus far. One additional thing that could be added, if you take a look right here, we keep on using this thing here to actually retrieve that list. Give me a sec. Okay, so I'm back here. So what we're having right here now is this, as I was saying. Right here we have this part here where we keep on getting this list. Cool? But if you take a look at it, we keep on repeating that over and over. Repeat it here, 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 here. Now, the reason why we usually make function is so that we can use what we call the drive principle. Don't repeat yourself. So we can solve this issue by having a new function called contents that takes a stack and it actually returns that list thingy that we keep on using. Cool? So in the exam, they usually might ask you to create a contents function. Cool? If they don't ask you, you can do it this way, or you can actually create that yourself and use contents and pass the stack to it and do your regular operation. It's just more than one ways of actually solving your problem. Cool? So it's not much different than what we had before. It's the same thing. It's just that we're saving ourselves times instead of keep on doing that index operation thingy. And the reason why it's the same because this contents function is going to return that list. So when we apply this, when we apply this dot append method, it will work because contents will return a list. So we're applying this dot append not to the contents function, but to the list that it's returning. So all of the operations that we've been having before will still work. Cool? So that's the first thing. That's for stacks. Now let's start taking a look at the Q data structure. All right. So let's go back to the drawing board. All right. Let me make this a little bit longer. All right, awesome. So now let's take a look at queues. So our queue data structure. Cool. Once again, we have to use the same list because remember I said order is important for both of these data structure. Now, for our queue, the easiest way that we can add values to our queue is by just appending once again. Just keep on just adding at the end of our list. But guess what? Remember what I said, for a queue data structure, it is the first thing that we placed in. The first thing that we placed in will be the first one to come out. So, therefore, we add to the list using the dot append method, but we remove from the list using something else. How can we remove from this list? Well, we can simply use pop and pass index 0 because remember I said the pop method takes an index. Index 0 was the first one that we added to that list. So the first in is the first one out. So we add right there, add right there, add right there, add right there, add right there. Then want to remove, we do that pop thingy. Alright, cool. Now, for some person might say, okay, sir, well, I probably saw someone show me it a different way, where basically what they do is instead of appending to that list, what they do, they have their list initially, and let's say the list initially had 1. Then when they want to add a value of 2, they simply did this. They inserted it to the front, in front of that 1. That's what they do. Well, for that way, really and truly, you're adding using the insert method. Insert allows you to place something at a specific position, and they're inserting at index 0 because if you take a look, this 2 pushed that 1 all the way over. So the 1 was right here and now it pushed it over to this side. right? So that's what the insert method does. Now, because the first value is now at the end, if you want to remove, then what we would have to do is once again pop at negative index 1. Now, personally, I feel this way is just really and truly a waste of time, because as far as I'm concerned, it's just added syntax to remember, this insert statement and all this foolishness. It's just simple. It's one set of operations you're using for stacks and queues. This way is much easier. For the stacks and queues, as you can see, we're adding by appending. But when we want to remove, there's just a difference. With stacks, it's the that we placed in should be the first out. So we pop the last index, -1. Whereas with the queue, the first thing we inserted is the first thing we want out. So we just pop with index 0. For me, that's way much easier. Whichever one suits you, choose that one. Now for our queues, we have some specific terminologies that we actually use. We use NQ, DQ. I know these words are just weird. Just know how to spell a Q and just put an N and a D in front of it. That's all. As well as, we also need to check if our Q is really and truly empty. Alright? Now, NQ adds to the queue, DQ removes from the queue. Is empty just checks if it's empty. But what if we want to retrieve that first value without removing it from that queue? Well, we have a function called front. All front does is just like top. Remember, for stacks, we're moving from the top of the stacks. While with queue, as I showed you, we're moving from the front. So that's why they get the terminologies. For stack, we use the top function, and for queue, we use that front function. Cool? So once again, before we can even use these operations, we need to actually create a function that allows us to create the queue data structure. So all I need to do is create that queue function, and once again it return a tuple where the first index is stating what data structure it is, and the second index is stating that the actual data structure, which is a list. After we do that, we're gonna look at the isEmpty function. So we're gonna create the isEmpty, and that takes a queue. I'm just gonna use the letter Q to represent a queue. How do we know if it's empty? It is the same thing as stacks. We check if this section really and truly if it's equal to an empty list. Now for me, I already have a contents function that gets that index, so I'm just gonna reuse that. Remember, for your contents, we wouldn't use STK, we'd use a Q or something to indicate that's a Q, but I'm just recycling this because it will work for it as well. So all I simply do is return contents, pass the Q to it, and that list of the Q values, I just simply check if it's equal to an empty list. That's it. After we do that, I'm gonna write this function called front that retrieves the front of the queue. Now remember, we cannot retrieve the front if it's empty. So all we need to do is for front, we pass a queue to it, and we check if it's not empty. If queue is not empty, then we're going to return by getting the contents of the queue. And what did we say we used to return the front? It would be index 0. So we just pass index 0 there to that list of the contents we get. And if there is no front, simply meaning that the queue is empty, once again we can do like this, print that the queue is empty or return none. So for your purposes, I'm gonna do both ways and comment out one of them. Alright, so you can print queue is empty. I'm gonna comment out that one and use the return none statement. I prefer that way. Alright, now after doing that, we're gonna do the NQ function. So when I say NQ, we're adding something to the queue, so we need to take the queue as well as a value, how do we enqueue to it? By first getting the contents of that queue. And how did we say we should add to that queue? By just simply appending. It's no different, just append to the queue. So we call the append method and pass that actual value to the queue. Now the next thing that we're going to do is the dequeue function. Dequeuing, we do not need a value, so we only need to take the queue. How do we remove from the queue? We cannot remove from the queue if it is empty. So first need to check if it is not empty. Then we're going to get the contents of that queue. Then we remove from it using what method? The very same pop method, but we're popping from index 0 instead of index -1 as stacks would do. Else, if that queue is really and truly empty, then once again I can do the same statement, do that print statement or return none. Doesn't really matter whichever one I want to do, we can do like that. Alright? Now, have we completed everything? We've done enqueuing and dequeuing, which if it's empty, I will go at the front. And that's it for the queue data structure and the stack data structure. Alright? Any questions regarding those two data structures? Because on the exam you'll be receiving a test on one of these data structures. Let me get this error. Oh, they're saying it's already defined because I already need one there and one here. Alright, cool, ignore that. So yes, any questions before I move on? Alright, I'm still here waiting now. Based on no message once again, I'm assuming that you guys are all A-OK. Hopefully that is true. Let's move on now. So, for you guys, you know what I'm gonna do? I am not gonna delete this. I'm just gonna add to this one pane folder. I'm just gonna make this, export this as one big PNG file so that you guys can take a look at all the sketches of demonstration of the queues and all that stuff, so that you guys can use this information to, you know, basically give you a little understanding. Like probably a couple minutes before the exam, you just can just browse through this to get a quick refresher instead of to read notes and all that stuff. Alright, so let us move on. Alright, someone saying they're hearing an echo. Yeah, are you guys still hearing an echo right now? Try to see what's going on here. Alright, hearing clear now. Hopefully I'm not seeing that echo anymore. Alright, trying to tune this a bit. So let us move on. It was still present. Oh, why would this still be? Alright, let's see if I can rectify the situation. Alright, give me a sec. Alright, give me 1 sec. I'm trying to rectify this situation. Just 1 sec, everyone. Alright, just gonna do this one thing. Give me a sec. I'll be right back with you guys. Alright, are guys still hearing an echo? Alright, hopefully not. Hopefully everything is quite fine. Alright, so let us continue to higher order functions. Higher order functions. Alright. Now, right here, for higher order functions, I think probably what was causing this echo part here is due to the fact that my battery has been low. So I just got the charger and plugging it back in. Hopefully everything should return back to normal right now. Streaming on low battery usually causes the issue. Hopefully that's rectified now. So now back to higher order functions. Really and truly, higher order function is just simply this. Higher order function is just simply passing functions to a function. Now remember, a function, like let's say we have def func, and it takes a parameter. In Python, we do not specify what this parameter should be. Usually in our coding, we're expecting it to be a specific value. So if we're supposed to compute like some value like we're gonna return, like we're probably gonna return a plus 1. It therefore means we're expecting a to be some number. If we were adding a plus the string me, we're expecting a to be a string. Whoever is calling this function should be sensible enough to know that, hey, it's a string should be passed. But really and truly, Python doesn't restrict whatever the person wants to pass. The person could pass a list, and that would cause this program to crash because it's expecting a string to be added to a string. Yes, so it got a list. So if we can pass to a function Just put a passing there again. We can pass a list, tuple, what's going on with you? Dictionary, strings, number, whatever it may be. If we can pass these for functions, why can't we pass another function into a function? Because when you define your function in Python, if you want to execute what's inside the body of that function, then you'd have to call the function by writing the function name followed by parentheses. And if the function takes a value, then you pass a value into those parentheses. But if you just say function name only, it will never execute what's inside of it. So it must be wonderful if we could pass a function to the function, because we know that calling a function name by itself doesn't execute it. We literally have to use the parentheses followed by parameters if it takes any parameter to actually run this function. But if we write down the name by itself, it will not run the function. So therefore, it means that we can pass a function name to another function. And inside that function, we would actually call the function. So let's say it's a function, we could actually call it by writing back a followed by parentheses. That's all our other functions are. So let us try an example. So I'm going to call this tutorial 2 WI. So now here I'm gonna have higher order functions. So now let's say I have a function called add, and it takes two values, A and B. What it does, it returns A multiplied by B. And I have another function called subtract. It takes A and B. What it does, it returns A minus B. I have another function called what's going on there? Multiply. I think that's how it's spelled. And it returns A multiplied by B. I have another function called power. It takes A and B, and it returns A raised to the B. Right? Now I have another function I'm going to call divide. It takes A and B, and it returns A divided by B. Alright? Now I can have another function that called operates, which takes two values and does some operation. And the third parameter is a function where all I simply do, I return calling that function and pass A and B to it. You might say, okay, sir, this is utter bullshit. Let's see how this works. Let's say I call the function operate, I pass 3 and 4 to it, and I pass what I want to do. I want to operate on those two values, 3 and 4, by performing some form of addition. Oops. There should be a plus sign. I want to perform it by doing some addition operation. I can pass the name of the function add to this function called operate. Because guess what's gonna happen? My function add is just passed as the third parameter to this function called operate. And what this function does, it calls that function that was passed by giving it two values. So in essence, this operate function allows me to perform anything on two values. So if I should assign this to a variable called result, and then I say print that result, let's see what happens if I should actually run this code. So it returned 7. As expected, 3 plus 4 gives me 7. Because what happens is that 3 and 4 is passed right here. And all the function operator does, it returns a call to another function. What's that function? Add. And when we call that function, we're passing 3 and 4. What does add do? It adds both of those values together. So now I can change that from add to subtract and see what happens if I run that. I get -1. And if I change this to multiply and I run this, I get 12. So you guys are seeing that? If you guys are not seeing it, just let me know. Alright, so based on what I'm seeing, no one is responding that they're having difficulty in understanding, so I'm assuming that you guys all get what's going on. Alright? So, right now, what I'm gonna do is, I'm gonna pause and I'm gonna hand over to a friend of mine to just take over a sec so I can do something and get right back. Alright? So he's going to take over explaining further about options.
Alright, so where Michael left off on high order functions, which are passing functions into functions actually. Okay, so where he left off was, I think he was using the operate function. So a high order function can also be declared as lambda. In 1127, you guys will be introduced to lambda function, which is a function within So I'll explain lambda until Michael comes back. He'll just be a short while. So, write a lambda function is quite easy in that it doesn't have to be declared like a regular function. You don't have to use the define keyword. Right? The define keyword. So, you'll start off with the keyword lambda. Right? Then you would give it a parameter, which is a parameter, say lambda x, and lambda x is going to operate on a function. For instance, say we're finding a function that finds the square root of a number. Then we will lambda x squared, right? So this is a fully functional lambda function that finds the square root of a number. We can set a lambda function to a variable, say a variable s, So S would now be the lambda function of x squared. Passing it into a function would be quite easy in that all we had to do was to say depth squared and then it would take the lambda function, which is s, any function actually, and the value of x. So it would return f to the x, which would give you the results. Yeah. So that would be passing a lambda function within a higher order operation, passing a function within a function. Another example of a higher order function is map. So while S is a lambda function that finds a square, map is a function that combines a function to a list itself. So the keyword map in Python is a keyword called map in Python, which is used in the map function. And the map function takes two parameters, which is the function and a list, right? So within the map function, we would pass in, say, a function such as x, which is that finds the square of the number, right? And what map actually does is that it maps each element of the list towards the function itself, right? So if you do, say, map, and then we use our same function that we created with lambda, which is s. If we map a list like 1 to 5 with it, it's actually going to map each element from 1 to 5 to the lambda function s, right? Yeah. So this would return a map. This would return a map function. If you want to view this, you would have to view it as a list, which this is called casting. So you're casting the map function to a list, so it will appear as a list, so you can see it. Because if you run it without this, you only see Python create a map object, which is some gibberish, right? Right? Yeah. Say, there's also another function called zip. What zip actually does is that zip takes in two lists or tuples, right? So it takes list 1 and a list 2, and it combines each of them, right? So say I had a list called D list, which is A, B, and C, right? And I wanted to zip it to an E list, which is 1, 2, and 3. So what the zip function actually does is that it takes these two lists and map each element to the corresponding element of that same index. So it would do A1, B2, C3, right? So example of this is that if you zipped D list and E list, it would give you back, as I said, A1, B2, C3, right? It creates tuples of each, so A1 would be a tuple with A being index 0 and 1 being index 1. And yeah, that's actually the zip function, right? So in hard out operations, these functions are used very frequently, being that it's very condensed because you can pass the zip function within an operation within another function to provide better coverage, better computational power. So as we can see, Michael has this function called operates in line 18, right? Line 18 takes in A, B, and a function, and then the function acts upon it, right? Say we're going to create a new function called that multiplies by 2 and adds 1. So we declare a new function, and we're going to declare a new function as a lambda function. So the lambda function would take in two numbers, right? And it will add them, it will multiply them and add 2, right? So what it does is multiply x times y and add 2. So this is a complete lambda function, right? So using Michael's operate function, we can then pass in 3 and 7, for example, and input our function called new function, right? This now actually, once it's run, just running this to see if it actually works. To see if it works, yeah. So what you can do is, yeah. So Michael has this in a shell, you know. So I'll just put it here for the time being, so then you can see the results. Cool. Some reason. Jeez. So I'm not seeing anything printing. Let's see. All right, so something with the compiler is using virtual pseudocode. So I'm not quite sure how this runs, but this is the right syntax. If you run it in Python shell or ideally, then it will work. Yeah. So you can try this on your machine. If it doesn't work, then you can send it in the chat or something. So we look through map, zip, and map and zip, which are two high-order operations. As a programmer, I've used map and zip a lot, and you'll be mostly tested on it in 1127. Yeah. So Michael has just arrived, and I think my time's up.
All right, everyone, back. Sorry for that delay and also being a bit absent. Just quickly gonna ask you guys, are you guys did you guys understood what we said so far? And I'm also hearing someone saying that they difficulty posting in the chat because it's requiring you to create a YouTube channel. That's the first I'm seeing that. For those of you who are having that difficulty, just post it in the 1127 project group, right? So whatever question you have or whatever you want to ask, just post it in that group. For those who are having that difficulty. For those who are not having that difficulty, you guys just simply can post it on the live chat here on YouTube. All right, so everybody good so far and understanding everything? Just need someone to do a little confirmation. Still waiting on someone to respond. All right, someone says we're still echoing. I really need to try and see what's going on for this right here, that echoing problem. It's not the internet that's the issue. Streaming is quite fine in terms of quality and everything. Don't know why there's an echo. Still an echo. It's strange. Alright, so hopefully there's still no echoing right now. But it's still having this echoing issue. For those who are still having it, not sure what much I can do other than what I've already tried to do. All I can do is get to the video after this stream so that you guys can rewatch it. Alright. So yes, for this right here so far, what you guys have been learning is the higher order function, and you've just been taught how to use it in a simplified way, and you've also been taught how to use the map using zip and lambda. Alright? Now, really and truly, just to reiterate over this. This map function works the same way the operate function that I made works. How do we know this? Because map takes some data structure as the second parameter, and the first parameter, really and truly, is a function name, or the actual function that is to be called each time it's taking out a value out of that list. So if I come right here and I have this right here, that's my list. And I have a function where it's taking some value and squaring it. For this first parameter, this function, this first parameter here, that's for this function for map, what it's doing is looping over this list, taking each value and passing to that function to get a result. Based on that result, it's using that to create a new list of information. Cool? It's the same thing that our operate function that I demonstrated to you guys earlier actually does. The function operates on two values. And the purpose really and truly of other functions is so that you can create something that is more generic. A function that can be applied to several cases. Now, here we're actually passing these types of functions, but that lambda function allows you to easily replicate things a bit much better. Because if you take a look at this, the add function, the body only has one line, subtract only has one line, multiply one line. Take a look at all these, it's just one line. All lambda does, it's a way in which you can pass parameters, separate them by commas, and what comes after that colon is what that function is returning. So if I wanted to replicate this divide function, all I simply needed to do was take a comma b, and after that colon I have a divided by b. So this is saying lambda is a function should take two parameters a and b, and after that it should return a divided by b. That's all that lambda is. It's just a simplified way of representing a function that only has one line of code inside its body. Cool? That's all this lambda thing is all about. Alright? So now let me just for that just use a demonstration of me using the lambda for this operate function. So now I can use lambda. It should take two parameters because operate is expecting a function where it takes two parameters because it's going to pass both of these to it. And I can let it be that what it's going to do is return true or false if A is less than B. So all it does, it returns true or false because remember, operators determines true or false. So equal operator, less than, greater than, those return true or false. So this is going to return true if the first value is less than the second value. Else it's going to return false. So let us try to run this and see what happens. So oops, I didn't save. That's right. And it returns true. Why? Because 3 is less than 4. Let me try something like 12 and see what happens. If I should run this code, I will get false because 12 is not less than 4. So therefore, this is one generic way. This operate function is a generic function because I can change what is happening to this 12 and 4 just by making a simple tweak to the function that is being operated on these two values. Cool? So that's really and truly the purpose of IR function. And we see evidence of this using that map function that was just mentioned. With map, I can use a lambda function or I can use one of these. So I can use add and I pass a list. So I have a list where 1, 2, 3, 4, 5. Alright. No, that's not gonna work. No, not that one. Sorry. I'm gonna change this to another function. Sorry about that. So I'm gonna make another function called raise. It takes a value and it returns it raised to the power of 2. I can pass that function to be the first parameter, just change it to pole. Cool. I can pass it as the first parameter to map, and all it's gonna do is for each of these values in this list, it's gonna raise it to the power of 2, and map is gonna create a new form of list. Cool. So this is a higher order function. Likewise, I have another function called filter. Filter, I can use this lambda expression that I have to filter out values from my list. So for my list, I could let it be where I have 1, 2, tuples of values. Cool. And I have to put these in parentheses. Alright. Now, what really and truly is happening here? This filter function takes the first parameter as a function. What this function does is it's supposed to be returning true or false. So if it returns a true value, then it's gonna keep that value that it picked out of the list. If it returns a false value, then it's gonna reject the value that it picked out of the list. So now right here, the first tuple, we extracted A and B out of that tuple, and we check if A is less than B. If it is, we're gonna keep it. So it's gonna keep this one, it's gonna keep this one. And if I made this one 12, it's gonna reject this one. Because why would it reject this one? It would reject it because A is not less than B. 12 is not less than B, so it's gonna reject that. Alright? So that's what's gonna happen. Alright? So let us actually see how we can use higher order functions, as I've stated, higher order functions to do some analysis on compound data structure. Because usually that's what you'll be getting in your examination. Alright? So let me just clear all of these and do this. So I have a data structure called students, where I have a list of students where the first part of the list is their ID number. First part of the tuple, I mean, is their ID number. Second part of the tuple is their grades for 4 courses that they do. Alright? So I'm just gonna quickly duplicate this, make some changes. We should go to let this person actually fill that course. And this person one. I'll let this person fill that course and fill this course. I'm so much like these lectures that you. Oops, did I just say that? Oh no. So much like these lectures that you're trying to do like a normal distribution, seeing patterning, you know, who is failing and who is passing. Alright, anyway, let's take a look at this. So what we're gonna do is just like a lecturer, try to find out who is failing and who is passing, and what really and truly is the average among these students. Now, the first question I'm going to do, what's the average grade overall for all these students? What is that average grade? Now, if we take a look at that, the average grade overall for all these students, we need one answer. One answer. This fold R, we're going to look at that. We need one answer. Alright? But we need to be extracting the grades from everyone. How can I find the average grade for everybody overall? I need to get these lists from everyone. How can I get it? I can simply use a map function. Let's get that out of the way. I can simply use a map function because what map does, it creates a new list from something. Alright? So, one way I can do is say map my first part map is x, and it's gonna get x index 1, because we're gonna loop over this list of students. So we're gonna pass that student into it, and each time map is called, each time map is gonna run, it's gonna pick each of these tuples. That's become our x, and x1 is gonna give me this list inside here. So really and truly, map gonna just create a big list with all of these right here, right? Now, after I have that, then what really and truly do I want to do? I want to find the sum of the values inside here, don't it? The sum of each value, don't it? So what I could do is right here where I'm getting 1, all I could do is, instead of getting 1, I could sum it. I call the Python sum function. Python sum function will sum together all the values that's inside of that list. Sum together all the values inside of that list. And then what I could do is divide that now by 4. So what did I just do? I just found the average for a specific student. Found the average for that specific student. So now map now is gonna store the average for each student. Now to find the overall average, we just simply need to sum all those averages and divide it by the total amount of averages that we have. So we have 1 average, 2 average, 3 average. That is 3 students. So the average is now summed up and divided by the amount of students. So I can now pass this to the Python sum function once again and divide it by the length of that students list. Now everybody gets that, or you guys are all lost, because this is using higher order functions to save us some time. Alright, so let me see what happens when I run this, provided that there is no other problem there. So we get that the overall average is 60.8333, going all the way down to 6. So going back over this, we use a higher order function called map, where we take each of the tuples of the student, and then from here we extract that list of their grades, we sum it together and we divide by 4, because we know that each student do 4 courses. Now from this, map is going to return a list of the average of each student. We sum the averages together, then we divide by the total amount of students, and we now find the overall average. Alright? Now, what's another way that we could do this? We could just simply add together all the grades, then divide it by the total amount of grades. Either way you work it, you're still going to get the same answer, 60.83336. Cool? So that is that right there. Now this sum function operates the same way as what fold R does. One difference is that if I should use fold R, I'd have to make that function for it to actually work. Fold R takes 3 parameters. Takes 3 parameters, of which the first parameter is a function that has 2 parameters. So inside that function it takes 2 values, where it's going to do some operation on them. So for us, we want to add them together. The second parameter that folder takes is our starting value, and the other one is a list that we're going to be plucking out things one at a time from. So really and truly, all folder is doing is simply this. If we have 1, 2, 3, right? What folder would do, if we want to sum them, we have to start at 0. Why? Because when we take the first value, we need to add those two together. And that becomes 1, which now is going to be used to add to the second value. That becomes 3. Then that's going to be used to add the final value. That becomes 6. And that's how we actually sum all values together in a list. Now, the reason why it's called fold R is because we're folding going on to the right side of the list. That's why they call it fold R. Fold right. Cool? So that's what fold R takes. But fold R function doesn't exist in Python. You'd have to make that one yourself. What exists in Python is the reduce function. And you'd have to import that from COMP tools. You'd have to import the function called reduce. So it's built into Python, and the thing with Python, we already automatically pick up that 0 thing, and if you run it, it should give you the same answer. But ignoring that thing that I said, importing right there, they will usually make that function fold R for you by default. You won't have to build it yourself. Cool? Alright. So, any more questions before I touch the last topic, which is list comprehension? Any questions? Alright. Guess no more question. Now, the last topic now is touching on that list comprehensions. Oops, 3.5. Alright. List comprehensions. Now, all list comprehension is simple. It's a follow format. We have what we're storing right there. Then we have a loop. Then we have a condition. And this condition is optional. So really and truly it can be just this and this. Alright? Now, all Python simply does, it's a simplified way of looping over some form of list, and we're taking values one at a time, and then we're gonna store it inside of an empty list. So we're adding to a list. So if we want to do something like this, let's say you want to keep a store of all the values from 1 to 10. We can simply write a for loop over a range. For I in range, if we want to go from 1 to 10, we put a start of 1, and then to 10 we need to put 11 because it's usually 1 less than it. If we want to store it, we put the I behind it. So this is what we're storing. This is our loop, and for us we don't have any condition for the statement. If it be that we want to store the squares of all the values from 1 to 11, 1 to 10, we can just square what we're storing. If you want to find the square root, so we'll just raise it to the power of a half. That's the same thing as finding the root of it. Alright? So list comprehension is a shortcut way, instead of you going about saying, okay, you have a list, make it empty, and then say, for I in range 1 to 11, then we're going to say list that append I raised to the power of half. Really and truly, this here is the same thing as this right here. Just that list comprehension makes things a bit more compact. And if you add an if statement, you're saying if I is even, so we check the remainder is 2. So if I is even, then we're actually gonna append to the list. We can just simply put our if statement right here. That is all this comprehension is. A nice compact way of shrinking your code. And trust me, guys, if you guys get questions in the exam and you see where it's just you're adding to a lesson, things like this, please, I'd recommend writing this comprehension. It saves you time and space on the paper instead of you writing that long loop. You won't be wrong if you write a long loop, but you'll actually improve your performance by using list comprehensions. Alright? Now, list comprehensions in themselves can be combined with folding right, filters, maps, and all those stuff. Right? Because what we could do is that right here, I could simply just have a map function. Where for my map function, I'm taking all the values from 1 to 11 and I'm adding 1 to it. And after I add 1 to it, then I'm going to loop over each of those values. Check if it's divisible by 0. Divisible by 2, sorry. And then I'm going to store the square root of it. So it's really crazy. You can combine list comprehensions and maps, and you can combine list comprehension with reduce, and all kinds of stuff. They're all interrelated. But one thing I want you to notice is this. A list comprehension that has a condition statement is no different from using a filter function. So I can repeat what's going on right here by using, so if I want to store all the values of I that are divisible by 2, it's no different than if I add the filter operation where I take a function that checks if each value is divisible by 2, and then it takes a list. My list would be that range. Right? This code here and this code here are the same. Filters and list comprehension are mimicking each other in most cases. The part where I had right here, where I'm finding the square root after filtering out those values, what I would have to do is, after I've filtered these values, I need to make some change to my values. So therefore, that filter now is now being passed to a map. So I would have a map where for each value, I'm finding the square root of it. And where am I getting those values? From what I've filtered out already. Alright? So list comprehensions where we have condition and we are not making any changes to the values that we're getting from the loop that we're to store, it's the same thing as a filter function. If it has a condition and we're making changes to what we're storing, it is the same thing as passing some filtered list of values to a map function. Alright? So that's how these two are interrelated. Alright? We're approaching the end of this marathon. Any questions? Any questions, anyone? Anything you'd like to question about? And this video I'll be making available right after this stream is over. Alright? Any questions? Alright. So far I am not seeing any questions. Not seeing any questions posted so far. So I'm guessing we have now come to the end of the stream. Thank you guys for watching. I ask you to please subscribe to YouTube channel Python Boss. And if you guys have any further questions, you can post in the group. But for now, that's it. Peace out, guys.